on glassy ice, pulling yourself with a kite, you know, and it turns out it's more like snowboarding in a variable gravity field while the moguls are moving on you. That's really what it's like, right? So, but once I'm set on a mission, I'm going to get it done. So as soon as I can get away from my, as soon as I have time to both be an awesome dad and carve out some time to do some sporty stuff, I'll get back on it. So, ladies and gentlemen, we're all here for one reason, and you guys all know who this is, right? What you guys probably don't know is, you know, Justin Bieber played a very big role on Mesos' success. Do you guys know that? Okay. So Justin Bieber, and I think this is around 2009 or so, tons of followers, right? And whenever he tweeted, Twitter had to send tens of millions of real-time messages to all their subscribers, probably mostly young women. And they ended up with an issue where they couldn't scale to meet their service requirements or the demand by the users. So you end up with this nice little picture that they later called the fail whale. And the problem for Twitter was not they didn't have enough infrastructure. They had a bunch of servers sitting around, but they had a monolithic application, right? And there was no server big enough that can carry all of Twitter's workload. So turns out one of our co-founders was childhood friends with the inventor of Apache Mesos, and they got talking, and Twitter became one of the first, you know, mainstream adopters of Apache Mesos. And you know, this to me signals a transition. It used to be when I began my career in the late 90s as an engineer, the future of the data center was defined by what was going on in Wall Street, what people were doing for, you know, foreign exchange trading and so forth. And over the years, it's really shifted towards the data centers that are being built by what we call web-scale companies, right? Google, LinkedIn, Twitter, so forth. And what we're seeing now is a lot of the Wall Street banks are looking at what the folks are doing in West Coast. Well, it's not an East versus West thing, right? But it's a lot of the high-tech companies are building technologies that also in Wall Street they're finding very interesting. So we're seeing a fundamental shift in how people use technology, both internally within companies to analyze customers, and also how they engage with customers. And we've seen several transitions of this going from the late 90s, where it's just about a web store, to now shifting towards doing analytics. In the late 2000s, there were a lot of efforts within large companies that were basically building data warehouses, right? And the challenge for many companies, of course, was it was hard to see business impact. So Gartner did a survey recently that said 50% of Hadoop users or enterprises are struggling to see value. And part of the reason was a lot of those efforts didn't start off with a business objective. Whereas today, a lot of the companies that are looking at rolling out modern applications have some real-time requirements. So just yesterday, Fred from Capital One was talking about how his project was started off by somebody telling him, hey, we want to do auto loans in a very, very short amount of time. Can you make that happen for us, right? And Fred said, yes, sir, we're going to make that happen. He shared a little bit yesterday on some of the transitions that they did at the company. And if you don't believe that the world is changing, then here's a more visual example. This is a photo from Vatican City around 2005, when the Pope at the time was changing. And you can see a couple of interesting things about this photo. One is there's a guy on the lower right with a phone. There's maybe another guy on the left with a phone, and there's two people staring at the cameraman for some reason, right? For me, what's interesting is not this photo, but how it compares to this photo. So what we see here is not just now everybody has smartphones. That's part of the observation. But the key fundamental change we're seeing is now everybody has an endpoint. Now everybody has expectations on end-user services. Bless you. Geolocation services. All these things are things that companies need to make sure they're being able to meet the expectations of modern enterprise and consumers. Some examples, right? Mayo Clinic going into personalized healthcare, big data, streaming data. These are all technologies that are key aspects of making this possible. Uber, we all know as a taxi company or a car hailing company, but Now they're getting into delivering food. So now, because I have a baby now and my wife works also, every night it's either that or, I forget, but there's a whole bunch of startups that bring food to you. It's pretty cool. And oftentimes they're paid for by the VC, so you get some really good discounts. And then Uber Rush sounds like a logistics and fulfillment type of service that they're experimenting with. So why can Uber do this? Because they have a platform and infrastructure that gives them the flexibility to go from idea to service in a very quick manner. And that's why they're able to innovate and disrupt multiple industries. So what we're seeing is a shift of the application architecture in the enterprise from when I started my career as an engineer, you had structured data. You had a large package app that you would create, and if it took 6 months or so to roll out a new change in feature sets for the enterprise users, that was okay. But today, that's no longer acceptable. We need to get to a place where users are not only enterprise employees, but also people on the internet, customers who are engaging you as a company and using your product. And of course, we all know data growth is really growing very quickly. And the only way we found out as a technology industry to solve this problem is to move towards distributed systems and build services that can actually meet those expectations of the modern world. Kudos to our snazzy design team for coming up with these beautiful pictures. So at Twitter, what they did was shift from a monolithic architecture to one that was more distributed in nature using microservices. Now, there are benefits and drawbacks to this approach. The benefit, of course, is you can scale only the components that you need. The drawbacks is now you have a lot more lines to manage, right? All the dependencies. And there are companies that we've spoken with that, at least at one point in time, manage their containers on spreadsheets, and which is not really managing it, but it's a way of tracking all the work that they're doing in their infrastructure. And if we step back, what is the fundamental transition in terms of the application architecture? Well, there's two main components, and you've heard a lot about this today, and you'll hear more about tomorrow. Building microservices and launching those things in containers. Oftentimes, these are stateless services. And the thing about modern apps is the whole system's not entirely stateless, right? When was the last time you used an app that was completely stateless, that wasn't something like Minesweeper or something, right? There's a lot of data that has to be stored. There's a lot of state that needs to be stored. There's a lot of incoming streaming information that you want to be able to process, and this is where big data services becomes very important and a fundamental part of modern applications. If you really step back and think about the transition that this community is helping to drive, right? Every fundamental business opportunity or scientific opportunity within the next decade will require a lot of this stuff on the right. Your right, not my right. The big data services. And why is that? Because all the easy problems have been solved, right? All the major opportunities, whether it's scientific discovery or business opportunities, will require processing lots of data and probably a lot of that in real time as well. So modern apps have several key components that make it as effective as it is. First, using open source software. When I was an engineer, I led a team that built the rules engine for Oracle CRM. I think today, you would just go get Spark or use something open source to get the ball rolling. Containers are a way of launching services very quickly and effectively. Microservices help you build things more quickly and roll them out. And data services, of course, help you capture the data. So this way, if you're a startup or you're a large company just starting off in a new area, open source becomes a very key force multiplier for you to be effective in building your applications. I thought this picture was pretty cool. I don't know what it is, but it looks pretty cool. Containers, of course, simplify packaging and deployment. I ran product marketing at VMware for 5 years, so I'm intimately familiar with virtual machines and how they work and what are the pros and cons of a virtual machine infrastructure. And when it comes down to modern applications, which are distributed, and you want to be able to launch services very quickly, you want to use containers because they spin up much faster than virtual machines. You can kill them much faster. You get higher workload density. If you have a virtual machine with 30 virtual machines, oftentimes what you are effectively doing is running 30 copies of Windows Server on it, right? That's a lot of resources that you can be using for the useful payload of your applications. And that's why containers are so effective and so popular today. We did a demonstration at Mesoscon last year that just showed on DCOS how you're able to launch a very, very large number of containers in a very, very short amount of time. And New Relic did a research a couple of months back that showed the average life for containers in many enterprises are oftentimes measured in seconds. Right? Services are launched, they do their work, they go away. You can really use your infrastructure a lot more effectively. Now, what's the point of having a container that can spin up very quickly if at the end of the day you're just running something big, heavy, and not really agile on it? And this is where containers and microservices become a very powerful combination, allowing teams to build services that can be deployed very quickly and having self-sufficient teams. You guys may have heard of the two-pizza principle. Anytime you have a team that's larger than can be fed by two pizzas, it's probably a little bit too big to build something effectively. I think that axiom also applies to meetings, right? If you want to do a problem-solving meeting, if it's a lot of people, it's hard to get stuff done. And the same principle applies here. So what you want to be able to do is empower the teams to deliver their services, maintain their API contracts with each other, and be able to just ship code. Because agile software is not whipping developers to code faster, it's making sure developers' code gets shipped faster. And that way you can have that virtuous cycle of product feedback and iterating and improving over time. So, getting to the last piece, data services, right? You guys are hearing a lot about that this week, and they are the backbone of the modern application. You can think of it as the bus between different services. You can think of it as a service that allows you to maintain persistence. And also, as we're moving towards modern applications, a lot of the, and you've been hearing a lot about this, the reliability, resilience is not being done at the virtualization or hardware layer. We're passing that up to the application. So you can have an infrastructure that can expect hardware to fail, but applications can still be very resilient. Right? So these four things, open source software, containerization, microservices, and big data services, together make the powerful combination that makes modern apps possible. So that's the application. What about the infrastructure? One thing to notice about modern applications is that they really changed the game for infrastructure. Virtualization, hypervisors did a tremendous benefit to many of us in driving up server utilization, in making sure that the management of infrastructure was no longer a physical activity, but a logical activity. So you can manage things virtually. But the challenge here is when you get to distributed systems, all those benefits of pooling the infrastructure went away. So the world is now crawling back when they're using distributed systems into a siloed world where they're having dedicated clusters, right? And in my mind, whether you have a dedicated cluster in your data center or you have it in the cloud, so it's somebody else's problem, you are having a picture that looks something like this, right? Whether it's in your data center or on AWS or on Azure and so forth. And this fundamentally needs to change if we want to get to a world where we can tackle all those, remember the big bubble of the modern app, all that data, all those users. We have to find a more effective way to pool and run this modern application elastically. There's another report that I saw recently, I forget the vendor or the analyst firm, but the outcome was 30% of all the machines that they surveyed were comatose. Right? And what they meant by that is these are machines that have virtual machines or logical applications that are sitting on it that haven't been doing anything useful for at least 6 months. Right? So in many data centers, there's a lot of that. And some of my old clients, when I was a consultant, said their best practice, not really a best practice, but their practice was to unplug stuff and see if anybody complains. Right? And you guys can relate to this. Some of you guys might actually do this. And if nobody complains, you can keep it and reclaim it. If somebody complains, you plug it back in, and who knows what happened. It's just, we have to fix it. And this is the world we have to get away from if we want to be able to provide services at the speed, at the resilience that we want to get to. And this is where we really need to look at, what's tolerable to us as professionals running infrastructure, and what do we want to address? Because currently with this setup, you have very low utilization. It's very manual. We have customers that will tell us, they have I'll use a silly example that I just made up. but very consistent with what we're hearing. If a company said, hey, we make toothbrushes and we want to roll out Wi-Fi chips in our toothbrushes and help customers figure out when to schedule their dental appointments, when they need to change their brush heads and so forth, and the business unit wants to do this, and they go to the app guys and they go, oh, I know what I need. I need Kafka to take in all the data that's coming in from all these IoT devices, a way of processing this, a way of matching that with doctors and creating a lot of different systems that I need to build, including, let's say, Spark and Cassandra. So then they say, great, let's go to the infrastructure guys. And the infrastructure guys will say, OK, so I need a Cassandra cluster, I need a Kafka cluster, and I need a Spark cluster, and then there's all this other stuff I need to get. And I'm going to need budget for that. See, this is all tied to the physical world all of a sudden, right? And so people have to buy servers. And when you have to buy servers, you got to ship them, right? Or you can go to AWS, but the problem is actually not very different because now you're still running all these things in separate logical systems. So we have to ask ourselves, what are we OK with, right? So if you guys saw a user interface window pop up like this, none of you guys would be happy, right? That's not acceptable to us. I expect my operating system to take care of that for me, right? So if that's not OK, then why is this OK? When we're living in a modern app context, right? And the only reason it's OK to us is we grew up in a world where we had to address this. I guarantee you our children, or my son when he grows up, if he's doing engineering, he's going to laugh at us that we had to do stuff like this, to manage these things as separate things. So, and we've solved this problem with the operating system, and that's why we have to look at how we think about the data center very differently, right? The modern app is no longer sitting in one node, it's sitting across nodes, and the only way to logically manage this effectively is with something that can abstract the whole data center as one logical form factor that you work against. And it turns out this too can be solved with abstraction, right? And that's what the power of Apache Mesos comes from. It's a two-level scheduler architecture that, as Ben Hyman would say, was engineered to be just stupidly simple, right? And so its only purpose is to basically manage resource offers and also workloads that are needed by the different schedulers or frameworks and aggregate them. And with this approach, we can now finally pool distributed systems. And the main reason, and this is the main focus behind Mesosphere's effort to make Mesos easier to use for mainstream enterprises. So just in case if it's not clear, because sometimes the wording is the operating system for the data center and the data center operating system. But wait, my Linux operating system sits in my data center, so how does this all fit? Right? So it doesn't. Every server in your data center will still need its OS. Microsoft's working on containerization technologies for Windows, and right now most deployments are on Linux-type environments. And the DCOS basically aggregates all these nodes in your data center, whether it's on-prem or in AWS, which is actually a very common workload, common use case for us. So Mesos runs agents in each of the individual nodes, and through a combination of master-agent coordination, we aggregate all those resources so that they can run distributed applications. So that's the data center operating system, aggregating multiple nodes so you can run common distributed systems at scale. And with this approach, what you find is now you can get back away from managing physical or individual nodes or servers. And you're able to try out things much more quickly. If somebody said, hey, we want to try out Spark or we want to try out Kafka, those things can be done very quickly. And I'll actually show some examples for you. One of the things we did earlier this year was to open source the DCOS to really bring modern apps and the power of modern apps to all enterprises. So this photo, I was going to put a photo of a pavement being created to show that we're helping people get there. But when was ever rolling out an application as simple as just riding in a car, right? It's actually a lot of work. So these guys are building a trail as part of a community, and we work with Lightbend and many other partners to bring this DCOS project to the open source community. And we actually have active working teams to look at areas of the DCOS that we want to continue improving on together as an open source community. So that's all great, Ed, but what does that actually look like? How does it work? I'll give you some examples. So this is the user interface for DCOS. And unlike virtual machine or machine-centric management platforms, you're not really focusing on the individual nodes. All the command line, all the user interface looks at the data center as one logical entity. But we do have tabs if you really like staring at nodes to be able to click on that and see what are the different nodes in your data center or cloud and what are the services that they're running. So who here has installed Spark before? Okay, great. Fantastic. So take a look at this. So this is installing Spark on DCOS. So was it like that for you guys when you guys installed Spark? Maybe not, right? And maybe you're more of a command line guy. So let's say all of a sudden now you need to install Kafka on the same cluster. There, you're done. So now Kafka is installed on a shared platform or shared cluster with Spark. You can do the same with Cassandra as well. By the way, question for you guys. Did it take longer to type the command or for the actual service to get installed? Did you guys get a sense? Who thought it was longer to type the command? Okay, longer for the service to be installed? All right, sounds like, so I actually timed it last night because I was like, I'm gonna be presenting to all these people. This typing is way too slow. So disclaimer, I did fast forward this by about 30%, but it didn't help because the typing took so long, right? So it turns out the typing was 5.8 seconds, and the service install after you type yes was 5 seconds. You scale that up by 30%, that's how it actually works on DCOS for the demo environment that we put together. So that's installation of services. And let's say you had to upgrade Kafka. This one's not an animated GIF because I didn't get time to set this up. But the experience is quite similar, right? So Kafka, Cassandra, Spark, all the services that work on DCOS, particularly the ones that Mesosphere and partners work on together to make sure that you get the enterprise level of quality and support. Because the universe on DCOS, anybody can publish to it, right? So there's a set of apps that we curate and work closely with partners on to make sure you're getting enterprise grades quality and of the code and performance. But upgrading Kafka, Cassandra, Spark, those are all similar experiences to this, right? Mouse clicks or command line interfaces, and they can be done very easily. And the universe, of course, is a very key. The reason why we call ourselves a data center operating system, aside from the fact that we're really thinking about it from a very computer science standpoint, in terms of building out our product, to build the operating system for the full-scale data center. The other angle is we want to make our partners successful, because an operating system is only as powerful as the apps that sit on it. Otherwise, why would you need an operating system? You'd just be playing around with something that's not quite useful. So we have many partners that we work with. It all starts from the open source technology, but we have many partners we work with that have their go-to-market, that have their business built on these open source tech. So this provides a way for folks like you to try out DCOS, try out the open source tech, and if you go, you know what, I really want Spark, I really want to have an enterprise grade set of services that work with Spark on top of Spark, they're vendors you can work with to make that happen. And we bridge that for you. And I invite you to take a look at DCOS.io. You can actually set up DCOS in a very, very short amount of time and try out Spark, Cassandra, Kafka, and many of the other services available in our universe. I'll walk through at a high level, conceptually, what are the components of DCOS. It starts off, of course, with Mesos. We talked about that earlier. We have Justin Bieber to thank for its mainstream adoption and success. That sits on the bottom. And of course, Mesos, being a two-level scheduler, needs frameworks so it knows what to run. And that's what we put up on top in the middle, the service manager. And there's two components to this, right? One is just launching containers. The other is launching stateful and maintaining stateful data services. So frameworks enable you to run all these distributed systems app services. Marathon, a very proven container orchestration engine, together become the part of the DCOS that makes service management easy and possible. Now, that lets you know how you can run services on top of a very resilient platform, but how do you install it? Well, that's the universe that you saw earlier. You click it, make a few clicks, pull in apps from either partners, or you yourselves can actually build frameworks that can be published to our universe. And so that makes up the right piece there. And then, of course, lastly, you saw the graphic user interface and the command line interface. Those round out the open source data center operating system. And then Mesosphere also provides, for license, Mesosphere Enterprise DCOS that includes features like security, capabilities like multi-tenancy, and more advanced features around networking and storage and troubleshooting and operations. So that rounds out what an open source data center operating system is, and then also what Mesosphere is doing to make sure that enterprises that really want a turnkey solution can have something that they can use to roll out modern apps very quickly. I'll wrap up with some examples from companies who are using DCOS and some of the impact they're seeing. So ESRI is a geospatial analytics company. They do some amazing stuff. I invite you to take a look at their website. A lot of it's on geospatial analytics. A lot of it's probably government related. And one of the things they do is they have to process real-time information coming in from IoT devices from the field, as well as other data points or data sources that they're processing. And by using DCOS, they told us that they were able to dramatically improve the processing throughput of how they're able to process geospatial data that's coming in. And those of you that are in the space know 3 orders of magnitude of improvement on anything is something, right? And this is what ESRI's been able to accomplish with DCOS. Another example is Time Warner Cable. This one's more of a classic large enterprise situation where they want to use containers, Docker containers. They have an existing OpenStack IaaS cloud, and they're looking for ways to really make it easier for their developers to roll out their new code. So by using DCOS, they were able to build a platform on which developers can ship code very quickly, and they're trying to evolve towards a DevOps model with a CI/CD pipeline. And services like Jenkins are also things that run elastically on DCOS to really make that a lot easier for enterprises. Last example, Verizon. We mentioned earlier how they demoed with us at MesosCon launching containers at scale. One of the main reasons they chose to go with DCOS is they see in the very near future that they need to run apps and services that will be touching tens of millions of subscribers. And there's no way they're going to be able to do that effectively if they're running this in a lot of different silos. I'll close with some data points around speed. So a big part of your roles as technologists are to lay the foundation for the architectural direction of your company, but also a big part of this is explaining to folks that are probably less close to the technology why this stuff matters. And if people don't get why speed matters, I think the data point from a McKinsey study late last year gives you some good insight. So they surveyed many different companies, 1,300 companies across a large variety of industries, and looked at their software development practices. And of course, as consultants, what they do is they take software and they divide it up into complexity units, and they look at how much complexity unit are people shipping based on the different practices they have and how well they're performing in various industries. And then so they grouped the companies into top quartile, bottom quartile, and second and third quartile, and made comparisons about their development practices and the impact on how they're shipping code. And what they found, I thought, was quite staggering. So the top quartile companies compared to the bottom quartile companies are, per developer, shipping code 3 times faster than the bottom quartile. The other data points not on this exhibit is overall throughput. They're seeing 4x more per company. So what that probably means is those companies are also investing more people. Well, they're actually using less people because they're so much more efficient, but overall they have higher throughput. And the last piece is they have 1/5 of the software defects in terms of the code that they ship. So I was trying to think of how do you visualize this so people get it, right? What is something that's 3 times faster than something else? And it turns out cheetah, well, it depends whether you're comparing cheetahs to Usain Bolt or an average runner. But it turns out cheetahs are around 70 miles per hour is their top speed, I think, right? And people, if they run really fast, is probably at probably a third or less of that, right? So picture that in your mind. You're a company shipping code, trying to deliver services to be competitive, and you got companies around you that are more like cheetahs, and then, is that a cheetah or a leopard? I don't really know. And then you have other folks that are actually, not working at that speed, right? So speed is critical for you to be effective in the modern world, and to be able to process that information, roll out code quickly is very important. That's all I have prepared. If you have any questions, I'll be right here, but I know lunch is also ready to be served, so thank you very much.